Hi everyone, welcome back to our daily question and solution. So before I start, I'd like to make a quick update. So moving forward from this week onwards, we'll only be uploading from Monday to Friday and we'll be taking a break on the weekends. It's also better for you so that you can take a break during the weekends as well. Okay, so with that, let's continue on with our question. So this question, I wouldn't say is exactly hard. However, it's a good opportunity for me to make use of this question to introduce the basic concepts of kinetics to all of you. So let's look at the question. Consider the reaction between gaseous compounds A, B, and C to form D. So the reactants over here in the overall equation are A, B, and C, and the product is D. They are all gases. The mechanism for the reaction was found to be as follows. So in step 1, you have A plus B undergoing a reaction, reversible reaction to give you X. This is a fast step. In step 2, which is the slow step, you have X, which is produced from the previous step, reacting with C to give you Y. And then in step 3, Y, which is produced in step 2, is then converted to D. This is also a fast step. Which of the following statements about the reaction and its mechanism is not correct? So then let's take a look. A, the units of the rate constant K are mole inverse dm cubed S inverse. So in order to figure out the units, I have to first write my rate equation. So over here, remember that your rate equation always follows that of the rate determining step, which is the slow step. Why is that so? Because when there are 3 steps, only the slow step is the so-called bottleneck. So for example, step 1 takes 5 seconds, step 2 takes 10 seconds, and step 3 takes 3 seconds. So over here, what is the overall rate? What is the time taken? Well, the one that determines the rate will be the slowest step. So definitely, since the slowest is 10 seconds, it will be 10 seconds instead of 3 seconds or 5 seconds. So this is why the slow step is the rate determining step, and the slow step is the reaction that will be included in the rate equation. So rate equals to K times the reactants of the slow step, concentration of X times concentration of C. However, if you recall, X is actually an intermediate. What is an intermediate? An intermediate is a reactant which is formed in one step and used up in the next. Okay, so therefore X is an intermediate and there can be no intermediate in the rate determining step. So therefore, I have concentration of A times concentration of B times concentration of C. So again, I cannot have an intermediate X. Therefore, I write down the reactants from which X came from, which is 1 mole of A and 1 mole of B. So therefore, this is my rate equation. Okay, so then I realized that overall, this is a third order reaction. And therefore, to get my units for K, let me see how to derive them. K equals the rate over concentration of A times concentration of B times concentration of C. So let's look at the units. So the units for rate is mole per dm cubed and then S inverse over. So the units for concentration is just mole per dm cubed. So I have it for all 3 of them. So it's mole per dm cubed. So then when I expand this out, what do I get? Mole cubed dm power negative 1. And then when I cancel, I get mole inverse 2 inverse dm. So this is negative 3 minus negative 9. So dm power 6 and then S inverse. Okay, so therefore, the units of the rate constant K It is not mole inverse dm cubed S inverse. So therefore this is wrong, and hence A is the answer. Let's take a look at B. The intermediates in the reaction are X and Y. That is correct, because remember what I said about intermediate? Intermediate is a reactant that is produced in one step and used up in the next. So X is produced in step 1 and used up in step 2. Let's look at Y. Y is produced in step 2 and used up in step 3. So therefore, this is correct. Okay, C, the rate of reaction increases with increasing temperature. So then you notice that all of these reactants are in the gaseous state. So therefore, since they are gases, they can be affected by pressure. So therefore, when the pressure increases, the rate of reaction increases. Okay, remember that rate of reaction is affected by concentration, surface area, pressure, and temperature. Lastly, D. The reaction is first order with respect to C. That is correct. So from rate equation, we've established that our reaction is first order with respect to A, B, and C. So therefore, overall, it is a third order reaction. Hence, D is right. Therefore, the answer is A. Thank you so much for watching, and have a nice day, and see you next time.